All right, now that I've gave you relationship advice with controlling relationships, this is kind of how we left off. We said controlling was a good thing, and we got to figure out what do we need to control. We need to control your spending habits. We need to think about the process parameters. Okay, well, I'm going to give you a card, and that card is going to have a limit on it. When you go over that limit, I'm sorry, you can't spend no more money for the day. You can't make us go broke one day after we get our paycheck. And then the process instruments and equipment. What's going to be needed in order to do that? Well, I need an extra little debit card so that way I can just give it to you and give it to you only. I need probably a computer system or some type of money transfer device that I can load up a certain amount of money on that card for you to go out and spend. And then when that goes empty, that just goes empty. And you know the sensor there, that sensor is going to be the ATM, or that sensor is going to be your little credit card terminal when you try to check out, because it's going to go beep, 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 beep when you don't have enough money to buy what you want. And then when you call me and ask me where that money's at, I'm going to sit back and I'm going to go, I told you, you should have listened to me and you didn't. So that's what you get. You didn't kind of take control of your own type of situation. You didn't monitor what you were supposed to monitor. And that's not my fault. That's yours, because that was what your job was supposed to be. All right. So with that said, that's what we talked about last. We now need to talk a little bit more details of process. So all processes need some type of control. Whatever control that might be, it needs it. And this is going to allow us to reduce what we would call variability. The key really always is we need consistency. All right. We need to be consistent from day to day to day to day. And process controls allow us to do that. So if it wasn't for those controls, we're not really monitoring anything. We are not getting involved when something goes crazy. And I want to be there and I want to fix those problems when they begin to happen. So if it's not for controls, then consistency is going to plummet. And depending on the day, depending on the week, depending on the work crew that is doing the job, our product and the quality of the product, the purity of the product, all of that is going to start to suffer. So process controls are very important for that reason. Disturbances can happen every day. That's kind of what they call that. And those disturbances can come in many different forms. Number one, it can just be the raw ingredients that we are using. Those raw ingredients, sometimes we don't have control of, right? We are ordering those from another place. They're getting shipped. We get them into the warehouse. Sooner or later, they get tested, absolutely. But those impurities can come along with those raw ingredients. And I want to make sure that we take care of those problems if they show up. So process controls are going to be in place, and they're going to help us with those types of situations or disturbances when they happen. Second is just variation in energy sources. So whether that's heat or some type of electricity, whatever, if that's involved in the process and in any form or any fashion, that can fluctuate from day to day. So energy sources are going to be very, very important. Number three, changes in the environment. So the environment is just really the surroundings. So what is there? What is the room like? Is it super humid? Is it super cold? Is it super hot? Is a rainstorm coming in? I mean, those are typically things that we don't think about sometimes, but the environment that these things are in will be changing from day to day to day. And that can actually affect some of these processes that we have to do and have to utilize in order to make these products. And I want to control those as well. Those are variables. Those variables are going to change, and I can do that through a little bit of controlling measures that we are talking about now. And finally, just human error, right? So human error, we're not perfect. We're not really meant to be perfect. We're going to make mistakes, and there's going to be some human error involved. I mean, from day to day to day, maybe I can do my job the right way almost every single day. And then maybe one day I just have an off day and I make a mistake and I don't catch it. Well, process controls are going to allow us to catch those mistakes if they are going to be made. So that way I can go back to the drawing board, and that way we can figure out how to fix that mistake and not ruin an entire batch. All right, that's what this is all about. Here's another image. It's just another schematic, and it says using sensors to control a tank level. So we kind of already talked about this, but now what we can talk about is not just 2 sensors, but in this case, there's 4. So one is a low sensor, and one is a high sensor. Those are sensors we've already talked about. So in the past video, I said, listen, we got a tank, we got liquid that goes into that tank. If it goes below a certain level, we get the beep, 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 beep. And if we get the liquid that goes above a certain level, we get the beep, 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 beep. Okay, so those sensors are going to drive me crazy. My noise effects or sound effects are going to drive you crazy. It's just the way that it is. So those sensors are going to be in place. They're going to let me know something's out of line and I need to get it back in control, and I need to kind of figure out what I need to do. Well, there could be actually extra sensors on top of that. And what you're seeing here is a maximum, and what you're seeing here is a minimum. So the maximum, that could be another sensor. And maybe if it goes to the high one, we get alerted. And that is an alert response. And that is saying, I need your attention. Please, somebody come and check on the tank. All right, so it's not going to shut itself off. It's not going to shut the plant down, but it's getting your attention because it's getting too high, and they want you involved in something so that way you can fix that problem, because it will be a problem if it goes unchecked. The maximum sensor, that is like the absolute tallest it's going to go. If liquid goes to the maximum sensor, it just turns the whole thing off. The whole plant manufacturing maybe can just completely shut down until we fix this problem. So that is a major issue that we need to fix, and that is going to be controlling the process. The same thing's going to happen with minimum, because if the liquid goes below the low level and it reaches the absolute minimum sensor, maybe that's what's there. I'm completely no, it can't go below that at all. If it does reach that, because an alarm's already went off, an alarm has already told you it's low, and hopefully you did something about it to fix the problem. But if you did not, and that liquid continues to drain, and that liquid layer still gets lower and lower, and it reaches that minimum sensor, then guess what? It just shuts down the entire thing all over again. So if it shuts down the entire plant, people are not going to be very happy with you. That's going to cause bigger problems in the long run. And these sensors are very important, and hence controlling each individual step along the way is going to be very important as well. So why are they important? Well, we just kind of talked about it, but number one, it's going to help us prevent injury. So if pressures go too high, if temperatures go too high, if tanks get filled too high, or maybe if things go too low, then actually some damage can happen. Things can blow up, things can overheat. I mean, we talking about all kinds of safety issues and concerns here. So it prevents injury. So that's a good thing. So that's why we like to control all of these parameters that can change on a daily basis. Next up, they are going to produce desired results. So this is going to help us give us what we want. So if we've got parameters in place and it says cut your oven on to 350 degrees, then I'm going to cut my oven on at 350 degrees. And if I cut my oven on at 350 and I follow the directions, I'm going to get the cake, and my cake is going to be really good. Well, if you did not cut your oven on to 350 degrees, then you've got a bigger problem. And that bigger problem is going to be your cake is going to turn out the wrong way. Nobody's going to want to eat it. And then they're going to go home, and then they're going to talk about you, and they're going to say, what an awful cook. I will never go back to their house for dinner. So we'll make an excuse the next time that they ask us over. All right, next up, number 3, we want to be consistent. So if we follow these control parameters, it will allow us to keep making quality cakes. So we're going to keep making quality product day after day, week after week, year after year. If I'm doing what I'm supposed to do and I'm checking everything involved in the process and there's controls in place, and there's ways that I need to fix those mistakes if they begin to happen, then I don't have to worry about major fluctuations in the product purity or quality. Number 4, it frees up time. So if these controls are there, and I don't have to constantly stand in front of a big, huge vat or storage tank and watch the levels of that storage tank constantly, then it frees up my time so that way I can walk away and I can go do something that I need to do, right? And then if an alarm goes off, then I can kind of pay attention to it and figure out what's going on. But otherwise, I would have to be there all day, every day with it to babysit it. And I don't want to do that, and you don't want to do that. So controls and all of these sensors and things that are in place will actually free up my time so that way I can go do something else that's going to be important. And then if something goes wacky, I'll get a notification in some form or fashion, and then I can go back and fix it and do what I need to do. Number 5, it prevents damage to equipment. All right, so with that said, we've already talked about it. So I was like, hey, remember that hot water tank? What if you go completely empty and your electric is still on and no water's in it? Well, you're going to damage your water tank. You're going to damage the heating elements that's going to be there. So we don't want this expensive equipment to be damaged because you have not paid attention. And these sensors and these controls and all of these variables that are going to be set for whatever reason, they are there in place to help protect that equipment so that way you don't accidentally damage it. Again, it could be hundreds of thousands of dollars for replacement, and nobody wants to be responsible for a company to replace that type of instrumentation or equipment because of your neglect. And number 6, it saves some time and it does save some money. So that way we can multitask. We can do 2 things at one time, if not more. That is going to save a little bit of time and money because time is money. So the less time that you're devoting to staring at a tank for no reason at all, and if you can do something else that's productive, that can kind of continue the manufacturing line and keep producing a product, oh, that's wonderful news. That's great news. That's what we want. Saving time and money is also kind of like your hot water tank, right? Think about if your hot water tank was drained every single time, and then when you wanted to use it, you had to go and turn the water on. And then you had to wait for the water to fill, and then you had to wait for the water to heat, and then you could go take a shower. Okay, well, there's a lot of time, and there's actually a lot of money there that you are wasting for no reason. Because maybe, just maybe, it takes more energy, more heat, more electric in order to get that big old vat of water to heat up from scratch versus keeping it on and keeping the water levels at an acceptable level, not too low, not too high, and always constantly keeping it warm so that way you've got hot water whenever you need it. That's also saving time and saving money, of course. Something else that I can bring into the picture and into the discussion is WFI, water for injection. So water for injection, absolutely. This is a process. It is a control process. So as we make water for injection, it will go into a holding tank, and that tank is supposed to continuously circulate it, making sure that it's still water for injection approved. It just constantly heats, keeps it maintained. It's not going to keep it stagnant into a holding area so that way gunk and nasty stuff can begin to grow. So water for injection will often be a process control that needs to be monitored, and that will include sensors, and that will control panels and everything else. So we're going to monitor those tanks. Of course we are. There's sensors that's going to be on those tanks, and it will actually tell us, hey, not only the quality, but it will also say, hey, you're getting low. And if you get low on water for injection, well, the rest of the manufacturing job can't do its job because they need that in order for their process to be completed. So we never want to run out of water for injection. That is something very, very important. If the manufacturing line needs it and they deem that it's a requirement, then we've got to make sure that it is there and it's ready to be used whenever they are ready to use it. So of course there's going to be minimums and maximums and lows and and high alerts. So we need to monitor these things, and we need to make sure that that stays in an appropriate level. So alarms are going to sound when we get to those lows or when we get to those highs. And then if we go too low or too high, this could actually shut down the entire thing until we figure out how to fix it and what we need to do in the next step. So in the next section, we are now in 6.5 if you are following with a book, and we're going to talk about more of process control parameters. What are some of the parameters that we do want to focus on? What are the most important ones that we can mention at least now? And we're going to kind of describe them in a little bit more detail, so that way we feel more comfortable with them and why they're important and why we should be monitoring them. So that's what you're going to see in the next video. I know, this one's a little short one. 15 minutes and not 45 minutes. Go figure, who would have known? He must be feeling great. Well, I think you just got lucky.